Hello everybody, Jack Rocknroll Amps. On the bench today is a very pretty Fender Deluxe Reverb, Fender Electric Instrument Company. From what I'm told, it's either a late 64 or early 65. Either way, it's an FEI co. So I'm looking forward to see what's doing inside, see what kind of updating it needs. And here we go, I'm going to start taking it apart. Here's the first problem right here. This cord was placed in here. It has no strain relief. It's just wrapped in tape. That's got to be fixed. I hope it's not an indication as to what's doing inside this amplifier. Oh, isn't that pretty? All original. Hasn't been touched. Look at this. Boy, oh boy. Well, at least it's grounded. Okay. Oh. Can you see that? Let's see if I can point to it. The hot wire is, I don't know, a heavy 1/16, maybe an 1/8 away from this screw. That's very special. So we have all original cathode bypass caps and all original capacitor for the bias. Let's take a look what's doing in here. This always amazes me. People do a job, they put 2 new caps in and leave 3 old ones in. Okay, well, we know those have to be taken out and replaced. All good. Okay, first thing I'm going to do is get rid of this. Next thing we're going to do is cut these out. By the way, this amplifier was discharged. Pulling out these capacitors. Okay, so let's start cleaning up. These are 25 UF caps at 50 volts. Doesn't hurt to put the labeling up so that it's easily identifiable by the next tech who has to look in here for some reason. Now this little stub here, I don't know if you can see it, right there, that is a continuation of this ground lead, so that has to be retained. I mean, we could make it shorter, but it's got to stay. I'm deliberately working this way so that I'm out of the way of the camera. It's actually pretty inconvenient, as I am a lefty. There we go. You can snip off the tail now. Okay, let's move on to the next pair right here. 1, 2, and there's the tail again. Okay, this one, I'm going to leave the stub in and wrap the negative side of the capacitors around it, because the chances of me getting in the 2 leads from the 2 capacitors, one goes from here to here, one goes from here to here, getting it into this hole is slim to none. So what I usually do is clean the oxidation off. You just rub it with a pair of pliers that have some teeth inside. All I'm doing is wrapping this around 2 times is more than enough. Cut this off. Try to do this right-handed. There's one thing about doing the work and then doing the work for the sake of the video. Look at that. Some people complain about these solder suckers, but you know what? They do a great job. They're inexpensive, and yeah, you got to clean them out often. Big deal. Deal with it. Because I also own an electric solder sucker, and that requires a lot of maintenance. That's why I don't even use it. It's a pain in the ass. I like to hold on to the stub, so as I'm twisting this ground lead around it, it doesn't cause any bending of the stub. I want it to stay straight up. Okay. When doing these videos, it's hard to concentrate on the different facets of doing the work, trying to stay clear of the lens so that the person who's watching the video can see what you're doing and that your hands and your arms don't get in the way. And then you don't want to burn the components inadvertently because you're thinking about something else. So you've got to keep your wits about you. Okay, one more cathode bypass capacitor to go. Oh, let's clean up first. I hate this cloth pushback wire. Such crap. It's annoying. Okay, again, this stub is part of a ground that goes back into the brass plate back here. So just going to straighten it out. And use it as a solder point. Well, almost time for a new roll of solder. Solder has gotten very expensive. It's like close to $50 for a roll. It's insane. Okay, let me see if I could tip this so you can see what's going on over here. Okay, so your bias capacitor sits here, and what you have over here, again, this is a stub that goes back to this ground over here. So the only thing that I have to do here is clean this out. Okay. Now, this stub right here, if you could see that, goes back under the board to here. So you got to leave that stub. It goes to this rectifier. So we're just going to clean the solder up. Jammed up my solder sucker. Oh, there we go. Nice load of solder. There we go. Very nice. Okay, now always remember that your capacitor for bias goes in reverse. The positive end goes to the ground. Okay? Sorry if my hand is in the way. Not much I can do about that at the moment. These are getting worn out. Okay, now I'm going to remove the bright capacitor, which is permanent bright cap that sits right here. It's a 47 picofarad. I have my theories on why Fender did this, but I'm not going to go into that. But traditionally, the bright cap is removed, and we save it just in case the customer wants to sell the amp, or maybe wants to put it back. But this is the only Fender amp that had a full-time bright capacitor. There we go. Out you go. Go into the customer's doggy bag. Now, I'm just going to touch up the solder on the volume control. Okay, this is a mistake. Whoever put this in here, put these in series. So this is hot. We go through here, and then you see this jumper wire goes back to the front of the positive side of this capacitor. So, and this is ground over here. There's the black wire. So these are supposed to be traditionally, if you look at the schematics, these should be 16s in parallel. Okay, so this, if you do the way capacitors work, when you have two capacitors in series, the voltages are additive, but the capacitor value in microfarads is halved. So these two capacitors are actually acting as a 16.5 UF capacitor at 900 volts. So these are going to come out. Okay. Let's see if I could balance this. Somebody actually went through the effort of putting shrink insulation on here. Ridiculous. And it feels like they're glued in place. Sorry, got to get my hands in the way. Go. This jumper wire does not belong here. Let's go up. Wait, down. Get that one out of the way so I don't burn it. Okay. These have to come out. Okay, this is probably strapped to this one. Okay. Or I should say, this one is strapped to this one, and this one is strapped to this one. So we can cut these. While we're here, we're going to also check the values of these 10K resistors, make sure they're still in spec. Actually, I'm going to do it right now. Very good. Very good. Very good. Okay, so what we're going to do is we're going to replace these 16s with 20s. Now, as I might have explained, if you look at the schematic for this amp, these first two capacitors are in parallel. They're not in series, which is the way some tech before me placed them in series, so that was incorrect. So the total capacitance here is 32 microfarads, which is the sum of this one and this one. So we're going to replace these with 20s, and all the other 16s are going to be replaced with 20s. I find it beneficial. Why? Well, I'll tell you. I think there's a slight tighter bass, better filtering of ripple. Might feel a little bit tighter all around. Maybe some moderate increase in headroom. Now, some people might say that you're going to stress the rectifier. Now, the maximum that a GZ34 should have is, if I remember right, is 50 microfarads at the first node. So these two in parallel are only going to be 40, so we're well within that specification. All right, so they must have removed, there should be a jumper wire over here. Now, I'm not going to glue these in because if you look at the original Fender cap can cover, it's got a like a foamy feeling rubberized piece of material that helps to press down on the capacitors. Now, it's true that today's capacitors are smaller in diameter, so this wouldn't reach. So what I'm going to do is add another piece of foam on top of this. If it wasn't such a vintage amp, I would probably just rip this out and replace it with a piece of foam. But I'm going to put a thin piece of foam on top of it to help make up for the difference in the sizes. And once this is screwed down, it'll press down on the capacitors and keep them firmly in place. So they will not have, there will be no effect of vibration on them. Okay, once again, try to put whatever information is on the capacitor facing up. All right. Doesn't make any difference to the capacitor, but it does make a difference to the next person who happens to come and do some work on the amplifier. Okay, just a little bit too long. Okay, where's my meter? Chances are this has no jumper in here, which it doesn't. All right, I got to get some jumper wire. This is just some bare 22 gauge wire. So I need one for the ground side and one for the hot side. I think traditionally this is called bus wire. I don't know the history of that, but I'm pretty sure that's what it's called. It's not a good idea to leave your bus wire hanging out where you're working, because sometimes, I know it's happened to me many times, where I grab the bus wire and went like this and stand here wondering why my solder isn't melting. Okay, I just wanted to show you that when you have the two capacitors in parallel, the 220 UF should add up to somewhere in the 40s or the very high 30s. So this is perfect, because don't forget that the capacitors could be plus or minus 10%, even 20% tolerance. So these happen to be very nicely, their tolerance is very good. So here we have 42.8 microfarads, which is excellent. Okay, now let's get to these guys. Gotta be careful over here. You don't want to ruin these wires, because they have to be used again. Get rid of this little stub. It's best to remove these resistors and clean the solder out. Otherwise, you're going to have to wrap your new capacitors around these stubs. And while it's not the worst thing in the world, I think best policy is to freshen it up and put everything back the way it would have been if it was brand new. Get a little more heat. There we go. Gotcha. Put you on the side. Putting your pair of pliers on the resistor lead also acts as a heat sink, so you're not killing the resistor with heat. Okay. I'm just, there's a solder pad right behind this reverb transformer, so I've just got to get in here and clean it out. The solder pad is the ground that covers these three capacitors. Okay, now I'm just going to show you something with the ohm meter. Right here is a ground. It's strapped to this one, as you can see, 0.2 ohms. For all intents and purposes, that would be considered 0. And then there's a strap that goes from here to here, which will show you the same thing. And then if you put this over here, you'll see that they're all common. Okay. So underneath this black insulative board are short wires that one goes from here to here, and one goes from here to here. By the way, if you're not really familiar with the workings of these amplifiers, before you take this all apart, I recommend taking a picture of it. Okay. Now we gotta tuck all these three wires back in here and the resistor, which it might be a challenge, because no matter how much solder you suck out, it's never the same as when it was brand new. Let me clean off all of the solder from the resistor. Try putting the resistor in first. See where that gets us. Okay, I got one wire hanging out. That's giving me a problem. Okay. Maybe if I get this good and wet and hot with the solder, it'll help me get it in there. Yep. Okay. everybody's in. This shouldn't be a problem. Famous last words. Gotcha. Okay. Oh, can't forget this guy. Okay, that's it. Let's see if we can find some room to pass it. Yes. Okay, made a mistake. Leads are too long. Very crowded terminal eyelet. There we go. You in there. Okay. This is the last wire. That's ground wire. Okay. Okay, so take a piece of foam, not this big, but I'm going to cut it. Give it a test run. Yep, that's good. Okay. So now I've got to find the screws. Okay, also make sure your wires are tucked in. All I like to do is take a used tube, spray some wash in here, and just plug this in, pull it out a couple of times, and hopefully it gets rid of some of the oxidation. The stuff evaporates very fast. These 60-year-old sockets are plenty tight. Okay, I want to check to see how tight these power tube sockets are. Good. Good. Very good. Okay. So, let's clean them out. Okay. Now, another thing I highly recommend is these octal clamps. There are different ways of securing power tubes to the amplifier. I prefer these. It's an easy install and they're very effective. Okay, now it's time to continue on with the cleanup. Now, I don't know if you could probably see it. These are heavily encrusted with oxidation. So what I like to do is grab my trusty Dremel. Grab a little wire brush, and actually a mask wouldn't hurt because a lot of shit goes flying into the air. Helps if you plug it in. By the way, you want to try to avoid hitting the faceplate because the wire brush will affect the paint. That reminds me, the cover to this is broken, so this has to be replaced. Okay. I have 1/4" bottle brushes, which I load into my drill. Take a little bit of this good stuff, and as I'm about to put it into the jack, just squirt it on. Slowly. Okay, for these, I just take an RCA jack, squirt it in there, give them a little rotation. Okay, all clean. What the hell was that? ground switch is coming out. Put it in a plastic bag for him. And this is going to be rewired modern. Okay. Pull out what they traditionally call the death cap. Oh. That goes in the doggy bag. On these amplifiers, way back then, the transformer lead was hooked up to the fuse, which is kind of ridiculous. I mean, today that nobody does that. What happens is the hot goes to here from the wall outlet, comes in through here, goes into your fuse, out of the fuse into the switch, and then from the switch it goes to the transformer. The fuse is the first stop. Oops, almost went to the standby switch. Just to the side. All right. Okay, you're out of there. Perfect. Okay, I'd like to put some thread lock on the inside. Try to show this to you. Okay, very nice. You vacuum this out. Okay, so this has to come in here, and I have to cut it back enough so that the ground reaches back here. The white wire is going to go here, and the black wire is going to go over here. Traditionally, if you could see in there, there's a copper colored screw and a silver colored screw. The copper colored screw gets the hot, and the silver colored screw gets the neutral. Alright, so let's approximate how much I need, and we got to skin this back. There might be other methods, but I've been doing this for so many years. I just use a safety razor, and I cut into the black rubber, not too hard, because you don't want to go through. And then you can give, a lot of times if you've gone deep enough, you could just take the white wire, give it a tug. And if it doesn't work, well, move on to the black wire, because maybe it's twisted inside. There we go. A little more. Yeah, it's twisted inside. Now we use the ground. Okay, good enough. that off. Okay, one of my favorite tools of all time. I'll show you in a second. This goes on here. This gets placed in the slot, and then you grab it with this, which is made just for this job and only for this job. Because if you've ever done this before, you'll know it doesn't need any further explanation. Done. Okay, now as far as the grounding goes, if you think you're going to do that with a regular soldering iron, dream on. You need something like this Sweller, which is 100 watt with a nice big fat tip. You've got to plug her in and let it warm up. In the meantime, we can get going on this. I don't like this just hanging out in here. You got to separate these. Okay. This one is going to head, I like to wrap it up into these filaments. Okay. Okay, it's going to go over to the switch, which I need to clean out the solder. Okay. Ooh, that's hot. Okay, let's clean this up. The other leg of the transformer is going to go over to here, to the neutral. So it's a vintage unit, so I'll try to keep as much of the wire as possible. Okay, there we go. This is going to go in here to the accessory socket. Give it a little hook. You can squeeze it down. Okay, that's not going anywhere. Now we could take our white. Actually, you know what? I want to do the black first. I'm going to hit this with a little bit of solder. I don't want to use too much because this is a heavy wire and it may not fit in the hole. Okay, that's a beautiful thing. See that? right in there. Okay. Now we need a wire to go from here to here. So I'm going to use a new wire for that. Doesn't have to be 18 gauge, but I happen to have some nice 18 gauge wire. So that's what I'm going to use. We're going to run it from where the power comes in. Nice fit. Okay. Everybody good? Yep. Tuck that baby in. We can go here with this guy. Okay. Now we take another piece, go to the other side of the fuse holder. To this side of the switch. Like I said, 18 gauge is overkill, but that's what I got, and it looks impressive. Hello, Dylan. Dylan's my buddy, my dog that came in to say hello. Okay, so now the white. 1 minute, buddy. Yeah, I hear you. I hear you. I do. Okay. Okay, so hot comes in, goes to the brass colored screw, then it feeds the fuse holder. Fuse holder feeds the switch. Switch feeds one leg of the power transformer. The other leg of the power transformer goes to the accessory side, the silver screw with the neutral wire, and then this guy is going to get attached down in here. Okay, so I think this should be very hot by now. So let me remove this old ground. I love the soldering iron. It doesn't take any shit. Strip back a nice piece. Prep it with some solder. Soak it down real good. Okay. You're just going to have to deal with my hands in the way. No way around it. Because I don't want to burn anything. All right. Unplug it. Let it cool down. And there you have it. Nice ground. All right, so this has been nicely tuned up. Again, power comes into the brass screw, then goes on to the fuse. Fuse feeds one side of the switch. The other side of the switch feeds the power transformer. The other lead from the power transformer goes to the neutral with the white wire, and green goes to ground. So, for all intents and purposes, we are done in here. You don't belong here. I might have to lubricate the pots. No big deal. Okay, all good. Let's see what the date is on these transformers. It's 65. Yeah, okay. Well, no matter what, it's still a Fender Electric 65. Could be an early 65. Okay, time to take a break. So, I'm going to take this hole plug and put it into where the nice metal hole plug, right where the ground switch was. And that looks pretty. Okay. Now here's the fuse that came with the amp. I checked it. It's the correct fuse. Okay, fuse is taken care of. Okay, all the tubes are in. Flip this guy over. Customer wants the original speaker removed, and we're going to put in an Eminence GASCX, which I haven't heard yet, but so far all the GA speakers I've listened to have been very good. Okay, so first thing is, this thing is filthy. So I gotta vacuum this out. These nuts are 11/32. One nut missing. Put this to the side. Put the reverb tank to the side. actually turn on the soldering iron so I could pull these off, and I'll probably put crimp connectors on there. Look at that. I thought they used all plywood, but this looks like pressboard to me. Yep. Maybe this isn't the original speaker. Look at that. Got some damage. The speaker is so light, I didn't even feel it in the box. And of course the studs don't line up so that you can put the speaker in straight. So I've got to put it off on a little angle. No big deal. That's life. I'm going to take the reverb tank all together. Everything is a problem. Time for some more vacuuming. When tightening up the nuts on a speaker, bring it up just snug. It's the way I do it. Now I see why this one was missing. This one is not grabbing. Anyway, when you snug it down, one hand, 2 fingers. No tighter than that. Two fingers. You go tighter than that, you run the risk of distorting the frame of the speaker. Now I gotta put the reverb tank back. Okay, putting new speaker studs on. New crimp disconnects. Making sure these will fit. Yep, very good. I prefer solder, but you know how guitar players are. They're in love with the speaker or a guitar or a pickup or an amp for a brief moment, and then they're ready to change. So in this case, if he wants to change the speaker, he can do it without getting to a soldering iron. Okie dokie. Alright, now it's time to bias the amp and test it. Okay, the amp is on, but as you can see, there's no power light on, no power indicator. So we have, let me turn this up, set to AC volts, one side to ground. So if I come to one side of the fuse, as you can see, we got 121 volts. The side of the fuse, it's dead. So the fuse that came with the amp is dead. Got to be changed. Okay, there was a reason why the original fuse was blown. I changed the fuse, turned the amp on, it immediately blew the new fuse. Oh, I pulled the GZ34 out with a replaced fuse, turned the amp on, and it stayed lit. So I changed the rectifier to a brand new JJ GZ34, turned it on, and the amp is working. Okay, so we had a bad rectifier. Got to add that to the list. Let's see what the bias voltage is. 48. Okay, it's safe to turn the amp on. Oh boy. All fixed. Anybody else? Okay, the reverb's working. Okay, let's see if this is working. Let's get a signal in there. Okay, all is well. Now let's bias the amp. In these amps, the tremolo doesn't work unless you plug in a shorting jack in the back. All right. Now that the tubes have warmed up, put this on standby. Volume's off, everything off. Okay, it's biased. There's only 6 milliamps going through there, so it's going to need an adjustment upward. $439. Okay, so I adjusted it up to about, it's a little bit over 20 milliamps on this tube. So as you saw just before, if I checked for DC voltage on the plate, I got about, let's call it 438. Do the math. We got 20.1 milliamps, so 438 times .0201 equals 8.80, right? Times, divided by 14. So 62.8%, 63% plate dissipation on this tube, which is fine. I'm not going to adjust it any further, but let's check the other tube first. Okay, this one is sitting at 20.5 milliamps. So there's no need to do the math again because that's basically within the same range as the other tube. It's probably like maybe 63.5% to 64. So for all intents and purposes, this is biased. Now, pull the probes. Just give it a little play through with the guitar. I'm sure it's going to sound great. Boy, that speaker sounds good. And that's with no back on the cabinet. Okay, so there you have it. That was a redo, brought up to date of this Fender Electric Instruments 65, probably an early 65 Deluxe Reverb. Great sounding amplifier. I hope you found the video useful, and now it's time to put it back in the cabinet.